Welcome back. In this lecture, we are going to primarily look into classic load balancer implementation on Kubernetes. But before going to understand about classic load balancer implementation using Kubernetes, so let's see on a very high level what is elastic load balancing in AWS. So in AWS, we have three types of load balancers available for providing the high availability for our applications. So those are classic load balancers, network load balancers, and then application load balancers. So to see in detail about all these three things in a feature by feature comparison manner, we have this link available for us, and then instead of a slide with all these features, AWS has documented it super, so we can directly see on the AWS documentation page. So we can see here application load balancer, network load balancer, and then classic load balancer. So the protocols each one supports is application load balancer is a HTTP and HTTPS level only, and network load balancer is at TCP, UDP, and then TLS protocols it supports. And classic load balancer supports both TCP, HTTP, HTTPS, and SSL. One important thing we need to understand about classic load balancers is this is a legacy load balancer which is going to get deprecated anytime in the near future. But another important thing about this in Kubernetes format is, like in relation with Kubernetes, is whenever we create a service in Kubernetes, right, a service object in Kubernetes, and of type load balancer, the default load balancer it is going to create on AWS is classic load balancer. So that's the important thing we need to know. And in addition to that, we'll have platforms like, as it is legacy, it also supports the EC2 classic environment and also latest VPC environments. So these are new ones which all supports directly the VPC environments, which is nothing but virtual private cloud. So like this, there will be tons of features available here, and most of the time the highest features supported load balancer is going to be application load balancer. If you see here, everything will be tick, 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 and then available for us. So with that said, we have a dedicated section for application load balancer, which is section 8, where we will be looking into creating an application load balancer from Kubernetes and then enabling the SSL for it, and then also enable the port 80 to 443 redirect. So like that, we are going to implement step by step the entire application load balancer in our section 8. But currently in section 7, whatever we are dealing, we are going to create a classic load balancer using Kubernetes and verify the same thing on the AWS management console, how the load balancer got created in AWS management console. In the same way, we are going to create a network load balancer and then test it. So all these things means, like, to create a classic load balancer or network load balancer, we are going to write a service Kubernetes service manifest and then verify whether it got created here in EC2 load balancers section. So that's about the thing which we are going to implement. So moving on, so if you see earlier, what we have done is, like, with RDS we have implemented the entire solution, but what we have done there is, like, we have used the node port service to test it. Okay, but now in a real production environments, usually we are not going to use node port service, right? Means like IP:port. We are going to DNS register our URL, and then with URL we are going to access it. So if that is the case, and we also need to have a port 80 or 443 things, right? Instead of 31231 or some other random ports, we need 80 or 443, which are the default browser ports for us, right? So for all those things, let's start with using one of the load balancers for high availability, and then start moving on with the next steps. Okay, so now with this design, we are going to add classic load balancer for our entire previous design, which is nothing but, we have seen this design earlier, which is not here. User management node port service is there. We need to replace this with classic load balancer. So before going and implementing the classic load balancer, we need to understand one important thing here. That is nothing but the EC2 worker nodes, which is nothing but the node group. EKS node group is created in the public subnets here. So, and the cluster control plane is also in the public subnets, and EKS node group is also in the public subnets. So ideally, where in a 3-tier architecture design, where we deploy our workloads, means like our application code in the private subnets, right? So with that said, now we are going to create a cluster control plane means like which will support the private node groups, means like the node groups created in the private subnets. So let's see that now, right? So in a AWS cloud, in a VPC, we have two availability zones. So we created a EKS cluster control plane. So what happens? So it also creates equivalent public and then private subnets in the availability zones where we have provided to create the cluster, right? So we selected during the cluster creation, our availability zones for our cluster is going to be 1A and then 1B. So it created public and private subnets in those availability zones. So next what happens is we are going to create a EKS private node group, which means earlier you have seen this instances worker nodes present in public subnet. So now they are present in private subnet here. So these EC2 instances will be created in the private subnet. So now how the communication is going to happen? Earlier it is in public subnet, it can directly connect to EKS cluster. But if it is in private subnet, it is going to leverage the NAT gateway to communicate it, provided if our API, cluster control planes API, Kubernetes API is having the public access. Even we can have it enabled internal, which is direct VPC access, wherein instead of going via NAT gateway, this connection can be directly to cluster control plane, okay, when we do via VPC access, okay. But for now, we will use the default and then standardized option, which is go via NAT gateway. So now our EKS cluster control plane service, we are connecting means like worker nodes, and then this cluster control plane is nothing but the master nodes, right? These are in communication using the NAT gateways. So the next thing is we are going to create our RDS database in the same private subnet, or you can create two more private subnets in two availability zones, and then inside them also we can create. But what I have done is I have leveraged the same private subnet, whatever EKS cluster control plane created as part of cluster creation. So the same thing I have leveraged here. So now I have the RDS database here. The next thing is its equivalent external name service we are going to create in these worker nodes, means like we are going to create external name service and then provide the Amazon RDS DB's endpoint URL for that to send the traffic to this RDS DB. And next thing is we are going to deploy our user management application, and then it will connect to the databases via external name service. So now here comes the classic load balancer. So this user management classic load balancer service we will create in the public subnet, right? And in addition to that, what happens is like now whenever users try to access the application, user management application, they use the classic ALB DNS URL, right? So this should be CLB DNS URL. I will change it. So using the CLB DNS URL slash user MGMT slash health status, whenever we access it, it comes to the classic load balancer, and from classic load balancer, the request gets distributed across different pods, right? So it will send to one pod the request, and then once from pod it need to identify its MySQL DB, right? So it will go to external name service, and then from external name service it is going to connect to RDS DB and then get the data. So if we have any users created, then those users we are going to access it. If no users got created, then we can go ahead and then create the user using the Postman project, whatever we have seen earlier. But on a high level, this is going to be the overall architecture which we are going to implement now. So to implement on a high level, what we are going to do is, currently our worker nodes are present in public subnet, so which we are going to delete them and then create our worker nodes in the private subnet, which is nothing but we are going to create a EKS private node group in private subnets. So as a step one, we are going to do that now. So I'll see you in the next lecture. Until then, bye bye. Thank you. Welcome back. So let's get into 07 classic and then network load balancers. So inside that, the first step is to create our EKS private node group. So let's go ahead and then do that. So we are going to delete the existing public node group and then create the new private node group, okay, in the private subnets, okay. So let's go ahead and then list our current node groups available in our EKS cluster. To do so, we need to provide the eksctl get node group and on which cluster it is available, right? So eksctl get node group, and on which cluster, our cluster name is EKS demo 1. So it will provide how many node groups available in our cluster. We have something called in a cluster EKS demo 1, we have EKS demo 1 ng public 1. Okay, so this public node group we are going to delete it now. So to delete it, eksctl delete node group and the node group name and inside which cluster it need to be deleted. Okay, so let me copy this and then paste it, so that respective node group will get deleted. So why we are deleting it is we really don't need to run anything on these nodes, right? So we are going to create everything in our private subnets. So that's the reason we have initiated this. So now let's go ahead and then create the EKS node group in private subnets. So the key option we are going to provide in addition to the previous whatever we have done in our other step, right? So if you open this here, so in the step EKS create cluster using eksctl, if you see here, we have created the node group here which is on the public subnets, right? So all these are same. Okay, only additional one option we are going to give, which is nothing but node private networking. So when we add this additional tag to our command, so it will create the node, all the EKS nodes in the private subnets. Okay, so that's what, all the worker nodes in the private subnet. So that's the reason we said node private networking at the end of this. And in addition to that, we also changed the name EKS demo ng private 1 instead of public 1. So let me copy this and then paste it, right? And then it is going to create our node in our worker nodes in the private subnet once we provide this command. So it's getting created. So it might take another 2 to 3 minutes to create this worker nodes. So I'll pause the video until then. So our node group creation in the private subnets got completed. So let's go ahead and then verify the stuff now. So where it is created and all those things. So verify if this node group is created in private subnets. So we can verify in two ways. One is kubectl get nodes -o void will provide the external IP address of the worker nodes. So far in the entire course, whatever we have implemented till now, so we used to get the external IP address using this command, and using that only with node port we used to test. So let's say clear and kubectl get nodes -o void. So if it is created in private subnet, it really will not have any public IP, right? So that's the reason external IP is none. Only we have the internal IP available for us. So this confirms that our Kubernetes node group has been created in the private subnets. But for additional verification, we can also do something like verify the associated subnet details for this respective node groups. Okay, so we can go here to the management console, right, and go to EKS Elastic Kubernetes Service, and in EKS demo 1 cluster. So if we go to networking tab, right, no, if we go to compute and if we go to our respective EKS demo 1 ng private 1, right, so this is the new node group, it has been created, and we can click on any one of the subnets here. Okay, so I'll click on one subnet here, and if we go inside that subnet, right, so the subnets associated to it. Okay, so this is the subnet associated to it. You can clearly see that that subnet has the private US East 1A, so which is created in private subnet. So for additional confirmation, you can even see the route table, right? So if you see, if it is a public subnet, it will go the outbound traffic or inbound traffic, everything will be via internet gateway and not the NAT gateway. But if it is private, means like via private subnets, means it is going to go via route table, will have the NAT gateway, via NAT gateway, whatever it is created, right? So this is the NAT gateway via which outbound traffic from our worker nodes is going to go. So one thing we need to understand here is, so let me go back and Let's get this up fully. Yeah. So now if you see these worker nodes, whatever is there, they will have the kubelet which will be communicating to the cluster control plane, which is nothing but EKS demo 1, right? So that happens via NAT gateway now. So that's what is the entire design. So this completes the creation of node group in the private subnets, right? So in our next lecture, we'll focus on implementing the classic load balancer. So I'll see you in the next lecture. Until then, bye bye. Thank you. Welcome back. In this lecture, we are going to implement this entire thing. So which is nothing but ODS database is already created and then ready for us. So what we are going to do is we are going to deploy the MySQL external name service and our user management deployment, and also we are going to write a classic load balancer service Kubernetes manifest and then deploy all these three things and then ensure that everything is working as expected for us when we access our application via browser. So let's go ahead and then do that now. So we will go back to our browser and we are going to 0702 classic load balancers CLB, right? And as a step 1, we are supposed to create our load balancer.yml, right? So let's go back to our Visual Studio Code, and if you see in 0702 in kube manifest, so we'll have the external name service which we have copied from our previous RDS database section. It is going to be same thing. And user management microservice also no changes inside that after integrating with the RDS database. So nothing, we are going to copy the same. Secrets also same, it is the same. And even the load balancer service, right, which is nothing but previously it is a node port service, the same thing we have copied here. Okay, so now what we are going to do is that respective node port service whatever we have created as part of RDS service, means like RDS database integration. So now we are going to change it to load balancer type. So what we need to do, earlier we used to create a node port service. So now we are going to create it as a load balancer type. Okay, our service as our Kubernetes service whatever we are going to create is a load balancer. And we already know that default whenever we create this manifest and deploy it in Kubernetes, it is going to create a classic load balancer by default. And one more important thing here is, because we are using the load balancer type, we really don't need to mention this node port here. Okay, so that one is removed and the type is load balancer is implemented. So done. Okay, so this default is going to be CLB. And now one more important thing here is port. Okay, so 8095 in browser also you can say CLB DNS URL colon 8095, or you can even use the listener port as 80. So which means like browser default port, right? Means like you really don't need to provide any port there. So you can use 80. In addition to that, if you want to change the name of your service, right? So little bit like CLB user management REST app, something like this. Okay, CLB user management REST app, and if you want you can even add service, whatever you want. Okay, so I'll say CLB, which is nothing but classic load balancer user management REST app. So that's all. We have done only 3 changes. One is we removed the node port here from our node port service, and we ensured that the type is going to be load balancer, which means we removed the node port here and then added load balancer. And then we changed the port to browser default port. So whenever we access our load balancer will be created with a listener port 80, right? Our service port is nothing but our load balancer port here, right? So which means on browser you really don't need to give 8095 something like that. Okay, so that's about it. Now this is completed. We'll go to our next step here, which is nothing but deploy these manifests. Okay, so I'm going to edit this section little bit. So ideally this should be kube-manifest here. So I didn't edit that. Now I have edited. It should be good now. So now let's go ahead and then deploy it. Okay, so we'll go to 07, and inside 07 we are going to go to 0702. right? And inside that we are going to say kubectl apply -f kube manifest. So where we have all the files there, okay? So now it is going to first create our MySQL service and also do the user management microservice deployment and its secrets thing, and also deploy the CLB user management REST app service, okay? So now we can say get svc should create a load balancer, and it also provided the load balancer URL here, right? You can see, and the port is 80, okay? So now it also created the external name service also, whatever we have implemented. So let me clear kubectl. I'll say get pods here, okay? And it's waiting for to come up. So if we want, we can parallelly check the logs of our application. So it came up successfully, no issues with the database. So kubectl get svc, right? So this is the load balancer. Usually it will take some time to get the load balancer spinned up, created, and then available for us. So let's go here and go to EKS. Now we'll go to service EC2 service, and inside that we'll go to left navigation load balancers, okay? So network and security load balancing, load balancers. So now you can see here the classic load balancer is getting created. You can see type is classic, right? And state still not available for us, so we can wait. So instances are registered, but they are out of service because of maybe our pod is still coming up. Once it comes up, it will take a while to register and then ready. So let's wait for a while. So it is in service now, so it is available for us. So health checks are passing. So we can copy the DNS name from here, whatever is provided, right? So this is the DNS name of our ALB. So we can directly use this, or we can even copy the DNS name from this section, okay? And copy this, and we can go to browser and say that DNS URL /user mgmt /health-status, right? So we can see it, user management services up and running. Want to even test the entire flow till the RDS database, so we can even go to our Postman and then create a user and then test it. So first list the users, so there should not be any users available by default. So let me cancel this. So first we need to provide the environment here, right? So let's go to settings and then add a environment, and it should be URL, right? And we are going to say CLB, right? And we are going to say http:// the entire ALB DNS URL, right? And then add it, right? And close it and go to CLB environment, okay? And let me close this, let's close everything here, and we'll go to list users once and then test it, okay? The environment we have selected is CLB, which is nothing but classic load balancer. So nothing, 200, no data available inside that. So let's go ahead and then create a user now, okay? So it is going to create a admin to user. So let's create it. So user created, and the error is related to notification service. We can ignore. And one more time, list services, and we should have the user available for us. So which completes the entire flow, which means from your browser you have accessed the load balancer, and then load balancer has forwarded the request to one of the pod here, and this pod has been sent to the MySQL external name service. And from external name service we went to RDSDB and then created that respective user. So entire flow we have tested. So in our next lecture we'll focus on network load balancer. So for now we'll go ahead and then delete all these things, okay? So I'll change this also to kube manifest, so not an issue. So let's go back here and kubectl delete -f and then kube manifest, and everything whatever we have created should get deleted now. So from Kubernetes, you have created the classic load balancer in AWS, and then you are also deleting the classic load balancer in AWS. So we really didn't touch any management console. We didn't create anything here. Okay, so everything is automatic for us. See, now everything is gone. So once we deleted, and our classic load balancer also got deleted. So this completes the classic load balancer demo, and then we'll see the network load balancer demo shortly. So I'll see you in the next lecture. Until then, bye bye. Thank you. Welcome back. In this lecture, we are going to create a network load balancer. So in previous lectures, we have created the classic load balancer. So now we are going to create a network load balancer manifest and then execute them or deploy them to create a network load balancer in AWS in our architecture. So only change means like the entire architecture is going to be same. Only change here is instead of classic load balancer service, we are going to create a network load balancer service. On a very high level, what is network load balancer service? We have seen earlier also, which is nothing but a TCP load balancer or a UDP load balancer, which doesn't need any HTTP traffic. Okay, which like it will be communicating at the TCP level. So whatever it is, my application allows TCP or HTTP, anything is fine for it. So I will use the TCP load balancer here. In regular use cases or in general use cases, like TCP load balancer are used for load balancing or providing the high availability features for the applications which doesn't need HTTP, maybe like a SMTP server or some other stuff, right? So whoever needs plain TCP load balancing, so we can provide using network load balancer. So now let's go ahead and then create the stuff. Okay, so we'll go to 0703 network load balancer NLB, and if you see here, so everything, entire manifest is going to be same as classic load balancer. Only one additional step will be there, which is nothing but we are going to add an annotation named NLB. So we are telling the Kubernetes, whenever you are creating this load balancer type service, also reference this annotation stating that use the network load balancer, which means whenever you are creating a load balancer, create NLB service, which is nothing but network load balancer service. So annotations are nothing but we are trying to tell them that tell the Kubernetes that we are giving the pointers that create the respective service based on whatever is provided inside it. Okay, so now we are providing and telling Kubernetes that create a NLB service here. Okay, so that it will create the NLB service, which is nothing but a load balancer. Okay, so now let's go back to our Visual Studio Code and 0703 network load balancer NLB, and here is the thing, I copied the entire stuff from CLB, and what we'll do is we'll change the name here to NLB, and let's add the annotations, right? Annotations, under metadata we are adding the annotation, and the annotation name is going to be NLB, right? So as usual, whatever is there, we have copied it. So now we have completed the network load balancer manifest. So rest all is going to be same. Type is load balancer. Selector for our pods is going to be user mgmt rest app, and port is going to be 80, and then target port is 8095. Okay, so now we will go back and then deploy this stuff. So let me come out of that, and then let me go to 0703. Okay, and kubectl apply -f kube manifest. So this should create as kubectl get svc, right? So now it is creating the NLB load balancer. So let's go back to our management console and then refresh it here. Okay, so it is getting created, and of type network, you can see it here. So it is creating a network load balancer now. So it will take a while to provision it. So once it is provisioned, we will look into it more. Good. Now our network load balancer is active now, and we can see the listener port, whatever we have configured here, which is nothing but port 80, is the same we have got it here. And we can even see the target groups, and inside target groups we can see both the targets are healthy, which means both the worker nodes are healthy, and then we communicate to our worker nodes with the 31984 to go inside and then access that respective pod. Okay, so now this looks good. So let's go ahead and then access our application. So we can say, we can copy this complete URL, copy, and then go to browser and then http:// and user mgmt/health status, right? It should be up and running. So we can even check this way, or we can go to our Postman, and here also we'll have our health status URL. So this is CLB URL. If you want to test for NLB, so then provide the NLB and then provide the URL as the variable, and the value is http:// and this value. Okay, so same should be updated in current value, add it, right, and change the environment to NLB, and then go to health status and then test it, right? So where is this? This is not notification. We need to check user management. Yeah, this is the one, user management health status, URL/user management health status. So it should look this way, right? So let me send it. So it's up and running. So earlier we have created the admin to user. If we send it, ideally it should list that. Okay, so if you want, we can even create one more user, admin3, and then even test it. Okay, save, send. Okay, created, and then list the users, and we have the admin3 created. So everything is working fine here. So our next step is to go ahead and then delete the manifest, right? So we have tested everything, so we can delete it now. So kubectl delete -f and then kube manifest, right? So this completes our NLB demo, network load balancer demo. So in our next series of lectures in section 8, we are going to focus on application load balancer, which is the very important one, where we are going to focus on Ingress concepts also there. So I'll see you in the next lecture. Until then, bye bye. Thank you.